In the last video, we looked at how to do long division with polynomials. We took this example, where we were asked to find the quotient, and this is what we did. We used long division to find that the quotient, in this case, is 3x squared plus 4x plus 5. In this video, we're going to look at another approach, sort of a shortcut to long division with polynomials that you might want to try. It's called synthetic division. So here I've copied that long division over here on the left, and I'm going to show you how to do it using synthetic division here on the right. So to start off with, you need to set things up properly. So here our divisor was x minus 3. And the first thing you want to do is you want to write down the value that would make the divisor equal to 0. So you're not actually writing the second term in the divisor here, which is negative 3 really. You're writing the value that makes the divisor equal to 0. So that would be positive 3. And then to the right of that, you want to copy the polynomial that's your dividend. Then you're going to make the synthetic division symbol, which is sort of an upside down sideways L, like that. You can almost think of it as being the long division symbol turned upside down, and that will be helpful to think of it that way if you like. Now, this is our x cubed term, this is our x squared term, this is our x term, and this is our, I'm going to call that our c term, our constant term. I'm going to leave those up there for a moment. You'll see why shortly. To do synthetic division, the first thing you're going to do is take the coefficient of your first term. Again, they all should be arranged in descending order of degree as they are here. And you're just going to bring that down and copy it underneath the line of your synthetic division symbol. Now, you're going to carry that up here and multiply it by this number. So I'm going to multiply 3 by 3, which gives me 9. Now I want to add, not subtract as I did in long division, but add negative 5 to positive 9. That's going to give me positive 4. And now I'm going to repeat. I take my positive 4, I'm going to carry it up here by multiplying it by this 3. So I multiply by 3, 4 times 3 is 12, I write my 12 down there. Now again I add vertically, negative 7, the coefficient up here, plus 12 is going to give me positive 5. Once more, I take this 5, I multiply it by the 3 over here, I get positive 15. Now I take my positive 15 and add it to the negative 1 above, and I get positive 14. Now, what I've got here are the coefficients, again, of the terms in descending order of power, but where this was x cubed and downwards, this is going to be the x squared term and downwards. So this will be the x term, this is the constant term, and this is the remainder. In other words, what my synthetic division has told me is that the quotient is 3x squared plus 4x plus 5, and the remainder is 14. The same result we got when we did the long division. Now, because I went through that quite quickly, you might want to go back over that on the video. Here's the steps that we took. First, you need to set the synthetic division up properly. To do that, you write the value that would make the divisor 0 at left, here. Then you write the coefficients in descending order of degree. So usually, if you were doing it, you wouldn't actually even write out the x cubed, the x squared, and the x here. You just write 3, negative 5, negative 7, and negative 1. Then you draw the synthetic division symbol, and you leave a little bit of space here for a row. Then you drop the first coefficient down, dropping down the 3, multiply by the number at the left, the 3, and write that number down here. Then you add down, adding the coefficient negative 5 to 9, you get 4. And then you repeat. At the end, you reassign the variables to the quotient, and each one should be 1 degree less than the dividend above. And that's synthetic division.